Example 10. The height of a tree is 15 meters. Tree is 15 meters. So you gotta use a little art. You gotta do art. To the nearest whole degree, what is the angle of elevation of the sun when the tree casts a shadow that is, okay, here's my little shadow. Sun's over here. Shadow would be 9.3 meters. It wants to know the sun's angle of elevation. So I'm looking for what that angle would be. So I'm going to draw my triangle. I'm looking for this angle of elevation because it's up. Opposite, no hypotenuse, adjacent. Tangent of something equals O over A. Use the inverse because we're finding an angle. There's a calculator. Second tangent. 15 over 9.3 equals 58 degrees for my angle of elevation to hit the sun. So my sun should be way up here, but pretend 58 degrees. Number 11, a meteorologist reads radio signals to get information from a weather balloon. The last alert indicated that the angle of depression of the weather balloon to the meteorologist was 41 degrees. Okay, let's say this is the weather balloon. Wow, it's really bad. Pretend it's a balloon. Its angle of depression from the weather balloon to the meteorologist. Angle of depression means looking down. So 41 degrees, looking down towards the weatherman. And the balloon was 1,810 meters away from his location on the diagonal. Oh, so the diagonal piece, that's the piece that's the 1,810. That's what gives us that tip to put it there instead of the horizontal. To the nearest meter, how high above the ground is the balloon? X. Triangle. This 41, I want it right here so that I have a triangle filled in. So I'm going to do the 90 minus the 41 to get the 49 inside. Cool, my triangle is all set up. No opposite, hypotenuse, adjacent. We finally get to use cosine. Equals A over H. Times by that 1,810. And we get X equals 1,810 cosine of 49. 1,187.5 meters above the ground. That's how high up the balloon is, the weather balloon. Last one. A sonar operator on an anchored cruiser, sonar operator on an anchored cruiser, detects a pod of dolphins feeding at a depth of about 255 meters directly below them. I don't know what a sonar operator looks like. I'm just going to draw a little boat. Below them, 255 feet, there are dolphins swimming. Okay, pretend those are dolphins. Dolphins. Meters. If the cruiser travels 450 meters west, never eat soggy waffles, west let's be honest, if you went east, you wouldn't be that big of a deal because it'd be the same if you solved it. They went 450 meters west, and the dolphins remained in the same depth to feed. What is the angle of depression? So I'm just gonna draw my triangle right here because this is the new boat. Angle of depression because it's looking down at the dolphins. So I'm trying to find that first. I'm just gonna deal with that question. So I'm dealing with this question first. Solving for x. Opposite, no hypotenuse, adjacent. That would be tangent of something equals O over A. Use the inverse. It's getting messy. Sorry guys. Second tangent. 255 divided by 450 equals 29.5. I'm gonna round up to 30 degrees. So this angle is 30 degrees looking down at the dolphins. Now, it also wants me to answer another question. So I'm just gonna redraw my 450, 255. I'm just redrawing the pink. What is the distance y between the cruiser and, edit, the pod? So here's my new cruiser. Here's the dolphins. Yikes. They want to know what this is, how far it is, that diagonal. Round your answer to the nearest whole number. A squared plus B squared equals C squared. 450 squared plus 255 squared equals the hypotenuse squared. 450 squared plus 255 squared equals a really big number. And to get rid of that power, I square root it. Second square root. 267,525, and we get 517.2. Round your answer to the nearest whole number. Whole number would just be 517. Is it meters or feet? Meters. That question's done. The end. Good job, you guys. We did it.